Another crucial protocol is HTTP or Hypertext Transfer Protocol, which uses port number 80. HTTP is considered insecure, and hence should be used together with TLS or Transport Layer Security. HTTP with TLS is called HTTPS. HTTPS uses port number 443. HTTP and HTTPS are Layer 7 protocols used on the application layer. That is why web application in browsers uses web pages with HTTP. Hello, welcome to the next episode of Get Certified Together program by TechnoCoff, your free online knowledge sharing community. Visit our website www.technocoff.com for more information. In this episode, we will be covering the next section of the CompTIA Security Plus certification exam. Let me start with the next topic of Section 3 for the CompTIA Security Plus exam, network and wireless security. Among these two, network security was always part of the plan of security architects, while creating info security strategies. Network equipments, like routers, firewalls, switch etc. are in use for decades now, and come with its own security challenges and mitigation solutions. However, lately, more and more wireless-based devices have been in use. Today's smart mobile phone has Bluetooth, Wi-Fi, near-field communications, or NFC, all inbuilt. Thus, wireless security is now considered equally crucial for an organization's security structure. Let us begin with network security. Network security is not only limited to securing your network infrastructure. It also covers securing access to network equipment, using the secured network protocols, transport layer security, etc. Before deep diving into how to secure any network, we need to understand what are the key components, or terms used, while deploying and maintaining any network. To begin with, we must understand the 7 layers of the OSI model. Starting from the bottom, these are Layer 1, Physical Layer, Layer 2, Data Link Layer, Layer 3, Network Layer, Layer 4, Transport Layer, Layer 5, Session Layer, Layer 6, Presentation Layer, and Layer 7, Application Layer. For every layer, security risks and associated impact will differ. This is because every layer has its own role defined, which brings with it a unique set of challenges. Any network uses multiple protocols to help a packet reach from source to destination. These protocols are used on various layers in the 7-layer OSI model. Each network service uses unique ports to identify itself when sending or receiving packets. The few most commonly used ports and protocols in the exam or in day-to-day network security work are as follows. First are TCP and UDP. TCP is Transport Control Protocol, which is connection-oriented, that needs a reliable handshake between sender and receiver before transmitting actual packets. UDP is User Datagram Protocol, which is connectionless, that transmits packets without any handshake. Both TCP and UDP are Layer 4 transport protocols. Another important protocol is Internet Protocol or IP. IP, which works on Layer 3, and provides a route to the server, to which packet needs to be transmitted. For this routing, it uses IP addresses, which are assigned to the server, the same as the room number assigned to the tenant in a hotel. IP address can be public, that is reachable from the internet, or private, that is reachable only inside the intranet or any organization's internal network. Another crucial protocol is HTTP or Hypertext Transfer Protocol, which uses port number 80. HTTP is considered insecure, and hence should be used together with TLS or Transport Layer Security. HTTP with TLS is called HTTPS. HTTPS uses port number 443. HTTP and HTTPS are Layer 7 protocols used on the application layer. That is why web application in browsers uses web pages with HTTP. Another crucial protocol is HTTP, or Hypertext Transfer Protocol, which uses port number 80. HTTP is considered insecure, and hence should be used together with TLS, or Transport Layer Security. HTTP, with TLS is called HTTPS. HTTPS, uses port number 443. HTTP and HTTPS are Layer 7 protocols used on the application layer. That is why web application in browsers uses web pages with HTTP. DHCP, or Dynamic Host Configuration Protocol, uses port 67 on UDP. DHCP is used for assigning a dynamic IP on a system, if we are not providing a manually assigned, static IP. DNS, or Domain Name Systems, is another important protocol, used for resolving the IP address of any system based on its FQDN, or fully qualified domain name. DNS uses port 53 on TCP. File Transfer Protocol, or FTP on TCP port 21, and Secure File Transfer Protocol, or SFTP, on TCP port 22, are used for file transfer to the system. Another commonly used protocol is SSH, or Secure Shell. It works on TCP port 22, and is used to access any Linux system. RDP, or Remote Desktop Protocol, works on TCP port 3389. It is used for accessing the Windows systems remotely. SMTP, or Simple Mail Transfer Protocol, on TCP port 25, and POP, or Post Office Protocol on TCP port 110, are commonly used for sending and receiving emails. SNMP, or Simple Network Management Protocol, on UDP port 161, is used for transferring alarms, as SNMP traps, from the SNMP agents, to central monitoring servers. The exam may cover questions related to protocols and ports, in scenarios like, which port to be used for certain requirements, or, out of given options, which is more secure. Let us move on to the next topic now, the concept of network zones. Any network can be broadly divided into three zones: intranet, internet, and demilitarized zones, or DMZ. DMZ lie in between the internet and intranet to run applications. For example, the web servers need to be accessible from the public network, yet should stay isolated in case of a security attack. Hence, the web servers can be placed in the DMZ. Additionally, three optional networks can also be created inside the intranet. The extranet is created for partners to access a few segments on the organization's internal private network. Normally it is made reachable to the partners via VPN or virtual private network. Another type of network is the honeynet. Honeynet is created for attackers to lure them to access and attack the intranet. Honeynets may terminate in honeypots, which are dedicated system devices created for the same purpose of luring the attackers. The darknet is an unused network segment, which can help in detecting the attack on the network, if any traffic is observed on them. Because darknets have zero traffic normally. All these networks can have two directions of network flows. One is the north-south. The other is the east-west. North-south traffic flows from inside server to outside network, while east-west traffic flows within servers, or virtual machines. Additionally, for enhanced security, networks can be segmented on Layer 2 using virtual LAN, or VLAN trunking, to provide isolation to different networks, allowing systems on the same VLAN access to each other without Layer 3 routing. Using VLAN, hence, also saves the overhead of sending every packet to the router. Let us move to the most critical part of any network, which is network equipment. Because there will always be actual infrastructure in place, responsible for managing the traffic. I will begin with Layer 2 and Layer 3 devices first, which are routers and switches, respectively. Routers operate on Layer 3 with the routing table configuration, along with IP addresses. This routing table decides the path for the destination of a packet, based on source and destination IP address. They can also provide the stateless inspection of traffic to block packets based on ACL or access control list. Stateless inspection means the router doesn't care if a packet is already allowed, as per an ongoing session. It treats every new packet equally and conducts ACL-based inspection. Switches operate on Layer 2 with MAC address and VLAN trunking information to decide the path for the destination of a packet. The next hop of the packet from the switch can be a Layer 3 router if the source and destination are in different broadcast domains, or simply put, have different IP address subnet. The destination can be another layer 2 switch, if both source and destination are in the same broadcast domain, or simply put, belong to the same subnet. Although layer 2 switches seem pretty simple devices, they can bring with themselves their own security risks. For example, ARP, or Address Resolution Protocol, or ARP spoofing, in which attacker can perform a man-in-the-middle attack by changing MAC address table inside the switch, which maps with destination's IP address. ARP, or Address Resolution Protocol, or ARP, works similar to DNS. While DNS performs IP address to FQDN resolution, ARP performs MAC address to IP address resolution. We can use various techniques for risk mitigation on switches, like VLAN pruning, which involves disabling VLAN on the network devices, if no host using them. Another commonly discussed technique is port security, which involves limiting MAC addresses on the switch port. While I am so much tempted to finish Domain 3 of the exam, in this week's podcast itself, unfortunately, the topic is very big and important. So, I don't want to flood a lot of information in one episode and overwhelm you guys. We still have crucial network security concepts to cover, like firewall, VPN, load balancers, network-based attacks, and of course, wireless security. So, better I keep things simple and cover them next week. This brings us to the end of episode 8 of the Get Certified Together podcast from Technicoff on the CompTIA Security Plus exam. In episode 9, I will proceed to the remaining topics of the domain security implementation. Thanks for listening.